Hi, my name is Julian Zhang. I'm an 8th grader at the Wells Middle School in the Bay Area of San Francisco. Recently, I did some research about orbital velocity. Orbital velocity is the speed of an object around an astronomical object. By combining my astrophysics knowledge with my computer programming skills, I created a computer program or calculator called AstroAssistant in my computer over here. So it automatically calculates the orbital velocity and it reduces error created by manual calculations. Before I start the explanation about my calculator, I'm going to explain a few concepts about orbital velocity to you and also gravitation by extent. I'll have my brother over there and to see if he could comprehend it. I think if he could comprehend it, you probably can. In our system, we have a planet and we have a rocket. So there are two major component vectors in an orbit: the forward velocity vector and the gravitational vector, which is denoted by v and g. To start, we have to point out the center of the planet to help us identify the height from point to point. Why is it point to point? Because astrophysics reduces everything to point mass. We have no surface area and no worry of collisions. Okay, so now we figure out the two components of the orbital velocity. We're now going to add them together. We're going to do something called vector addition. So we're going to have the red marker as forward velocity and the green vector as the gravity vector. So we now have these two vectors pointing at the different directions. We're going to add them by moving the gravity vector to the tip of the velocity vector. And then we're going to connect these 2 points together. And now we have the velocity orbit. So the orbit is going to curve that way into a circle or an ellipse. So notice the orbit isn't a perfect circle. It doesn't have the Earth as its center. So we have the center over here, and we need to figure out what the semi-major axis, or A, is. And we also need to figure out the radius of the object in orbit from center to center. And this is our radius. So the important equation that we're going to have here is also the core of the calculation is v squared equals gm times 2 over r minus 1 over a. So we already have r and a fulfilled, and we're going to calculate v. And g is a whole new another equation which is fairly easy and Newton predicted for us. So g is the universal gravitational constant, which is 6.67 times 10 to the negative 11th power. It's a very small number. It's a force of 1 kilogram object exerting gravity. And m is the mass of the Earth, which is a very large number, so these small number times large number is going to be a fairly large number, because 11 is smaller than 24. And so we have all of these together, and we are able to calculate the orbit. Okay, so this is my astrophysics calculator called AstroAssistant. So let's take a look at this. So it first welcomes you to the AstroAssistant, a physics calculator, and then it asks you to select your type of calculations. So 1 for orbital velocity, so we're going to do 1 here, and 2 for two-body calculations, which is the interaction of gravity between two bodies, and 3 for rocket efficiency, which is originated from the rocket equation. So 2 and 3 is now currently under development, so I'll give you an update when it's finished. So let's select 1. And please enter the name of gravitational primal in the calculation.
So this calculator doesn't require you to enter GM, nor the distance from the center of your astronomical object to your orbiting object. So if you select, for example, Earth, and it automatically selects the GM, which is also called mu, by the way. It automatically selects GM, and it automatically adds the body radius themselves to your height from sea level. So it's pretty convenient. Let's press enter. And please enter the height of that calculated object from the sea level. So very convenient. Let's enter 300,000 meters. It's a very common orbital altitude used by low Earth orbit spacecrafts. So, and let's enter the same for the semi-major axis, which if these two are the same, they're essentially a perfect circle. And enter. And the orbital velocity of your selected orbit is 7,729.88. Very convenient. Okay, thank you for watching this video.
Thanks for watching. Oh, wait. Here's a correction. The mass here shouldn't be the mass of Earth. This is planet 8, so it's going to be the mass of planet 8. When the mass is really big, you get a really large orbital velocity. When its mass is small, you get a smaller one. So, do you understand, Mom?
Well, check with your brother first. Action.
So,
Julian, we already have a calculator. Mama, 看我用绿笔。
好的。
宇宙怎么画呢？这是一个太阳，看，然后这里多一个星。我先说太阳的起源吧。起源对。你看，太阳是用星云来造成的。看，然后过了差不多到4年。对。4年啊。然后就爆发了。爆出好多火。